Okay, so hello everyone to another video which is on minimum cost climbing stairs. It is an extension of this problem which is climbing stairs and yeah, we'll try to solve this. I am working on the solution for this one itself. First of all, I will read the problem and yeah, it has been asked in Amazon, Apple, what else? I think Microsoft as well, Adobe, okay, Google, Yahoo, Uber, okay. So the problem states that you are given a cost array where cost I is the cost of ith step on a staircase. So you're trying to climb to the top of a staircase, and for every step that you do, you will have to find the cost of that step and add it to your total cost. Once you pay the cost, you can either climb one or two steps. So if you are at cost I, you can either go to cost I plus 1 or cost I plus 2. You can either start from the step with index 0 or 1. That makes sense, right? Because if we look, uh, let me try to visualize it, okay, for you. So this is the staircase that you are trying to reach, okay? This is 1, this is 2, this is 3, 4, and this is the base. And I think this is the top, okay? So from the base, you can either do this or you can do this, right? So which of the two steps you would choose? You would obviously choose which is having the minimum cost. So this is cost 0, this is cost 1. Whichever of these two will be minimum, you will choose that as the first step. Okay. So what we can know, at least for this, up till what we have read of the problem statement, that so this will be our solution, DP array. Okay. What we know is first step would be the minimum value between cost 0 and cost 1 for sure. Okay, so if we have a minimum cost array to calculate minimum cost to reach ith step, what we do know is so minimum cost to for zeroth will be, I mean, minimum cost to reach the first step, it will be the obviously the cost of first step, and the minimum cost to reach second step will be the cost of second step. This is interesting. To calculate the minimum step cost of the third step. For this step, you could have, so to reach this step, you can either take one step from here or two steps from here. So it is reachable from first and second position, the third step I'm talking about. Okay, it is reachable from first or second step. So which one you would have taken to minimize the cost to reach this one, third position? Which one you would have taken? Obviously, which was having the lower cost of these two, between these two. Okay, and to stand on this, you would have to also include the cost of this step. So you would have some cost associated with this position, third position, but what were the previous costs possible? They were, you basically chose the step which was having the minimum cost of the first two steps. So you did something like this. You would have done something like this. If this was lower, you would have taken this step and then jumped two steps to reach this. If this was lower, you would have jumped directly two steps first and then one step to reach this. Similarly, let's try to build the solution for minimum cost 3 as well. It's not needed, but let's do it. 3 in this case, it's an index, so it is referring to fourth position. For fourth position, you would obviously include the cost of the fourth position, first of all, because you are standing there. And you have to figure out whether this step was taken, whether this was taken, whether this was taken or not. Okay. But in this case, you only need to figure out, okay, what was the minimum cost of reaching these two steps? Because fourth is reachable from second and third. So from second, you can take two steps, or from third, you can take one step. So it is only reachable from second and third position. So you just need to figure out which of these two would incur the minimum cost to reach this. Okay. So you can just take a minimum value of minimum cost array. You can just do something like this. You can have a look at third position's minimum cost and the second position's minimum cost. And that should give you the minimum cost to reach fourth step and so on. For the top, you have to keep in mind. So in this case, top is this one. So top is reachable from third and fourth position only. So basically n minus 1th and n minus 2th position only. But top, we don't need to incur any cost. Okay, there is no cost associated with standing at the top step, right? There is only cost associated with each of the numbered stairs that are there. Once you reach the top, you don't have to incur any cost to stand there. For just like we didn't incur any cost to for standing at the base. So minimum cost to reach nth step will be, in this case, will be, I'm assuming n is top. We can just return the minimum of minimum cost n minus 1 and minimum cost of n minus 2, because n is only reachable by n minus 1 and n minus 2th position. So if we figure out whichever of them, those two positions, incurred us the minimum cost till now, we can just choose accordingly. So in this case, let's say this is the top and these two are the two positions before it. So n is reachable from only these two positions and none other than that. So you can either take two steps or you can take one step from here. Which one you would take? Whichever will be the cost effective for you. So this is what we are doing here. We are trying to find which of these two is a cost effective way to reach n. Okay, hopefully that's visible. That's clear to you. If that's not clear, it will be more clear when we write the code. Okay, let me put this aside. Let's go to code first. Okay, and let's see. Cost length can be 2 or greater. Okay, so basically, you would always have 0th and ith elements. Okay, so let's initialize our memoize dp grid, which will store ultimate result. Like basically, for every index, it will store what was the minimum cost to reach that. Okay, So we will have size n, I think. Yes. So we can have, it will store the minimum cost to reach ith step. What we do know is minimum cost to reach first step is the cost to reach first step. Minimum cost to reach first step, sorry, second step is the cost to reach second step. Cost of standing at second step. With that out of the way, we can just have a look at what we were trying to do. Okay. You can see a pattern here. So I'll just write a recurrence relation for this one. Um, from I2 onwards, minimum cost for ith position is equal to cost of standing at the ith position plus whichever of the previous two steps was cost effective. So whichever of the previous two steps was having a smaller cost, that will be used to reach this step, because we can take only for one or two steps. It is very, very important to understand this line that we did. Okay, very, very important to understand this particular line. And it's coming directly from this logic that we found. Okay. For every ith position, the minimum cost is dependent on the cost of standing at the ith position and the minimum cost of previous two. Okay, like which was the most optimal choice to reach this step, because we can take only one or two steps. So either of these two were optimal. And how to find that? We use math.min, and whichever was the minimum, we'll choose that. So we are trying to build our solution bottom-up approach where we are starting from smaller I values and going till the n. Mm, sorry, and I have to store first. Okay, so in the end, what will happen is we will have two options: either to include the last step or not include the last step, like this case or this one, to reach the top. Either we can jump from here or you can jump from second last position as well. Which choice you would make will depend on the minimum cost value that you've calculated for those two positions. So it will be minimum cost of n minus 1 and minimum cost of n minus 2. You can take the minimum of these two. That will give you the answer. Something is going wrong while our calculation. Okay, this should be 1. Okay, so it is working fine. Uh, time complexity. Only visiting one position once, so O of capital N. Space complexity. We are using a DP grid, which is minimum cost array. So O of this is also O of N, because it's size N, right? It was working. Let's try to submit it. Hopefully, so it's beating 100% and space is also beating quite a bit of submissions. So I think that should be it for this video, right? Uh, I don't think we can optimize on the minimum cost because we will require that. We need to store a certain position. Uh, but what we can optimize is on uh, we only are concerned with the previous two minimum cost values, right? So we can probably optimize on that, where we can just maintain two static variables, sorry, two variables, and we can just try to switch the values between these two. Okay, shall we try that? Uh, let's try it out. Why not? Maybe we would be able to. But I like this solution very much because it's easier to understand. But let's try to minimum cost. Let's call it n minus 1 minimum cost of n minus 2. Sorry. This is an in. I don't like the solution very much, but let's see. Uh, this is just optimization that I'm trying to achieve. I think that should be enough. And just copy paste this statement from here. So in each iteration, we are maximally using three variables. So that's the concept that we are trying to use here. That we only need three variables to switch the values between them. Okay. So once it comes to 2, it will take cost of 2, do the do the minimum of cost 0 and cost 1. It will store the minimum cost for 2. Now that minimum cost for 2 will become n minus 1 in this, for the next element. So that's what we're doing. Let's see if it is working. I want to see my array, how it looks like. We don't have array, but so for second it is working. First one we have to debug. Cos 0 and cos 1 are 10 and 15. Okay, it will take the minimum of them. Okay, cost of this position will be 20 plus 10, 30. Fine. Is it 30? Yes. Okay, here it should be this thing. So only these two should be considered, not these two. But this is already happening here. Oh, this is the issue. Yes, I think this is the issue. Yes, it is accepting. What was happening was for initial two variables, for n minus 1 position, it should be this, right? And n minus 2 should be the starting position here. So these variables were not properly assigned actually. That was the issue. Let's try to submit it. Okay, let me do this thing also. Let me remove this, and this also we can remove. So we did all this just to bring the space complexity to O of 1. Okay, so now it is beating 98%. Okay, so that's it for this video. Hope you guys found it helpful. Just let me know in the comments. Thank you. Let's meet in some other video and try to solve either graph theory or DP. So those are the currently two plans that I am working, and I'm creating videos for those first, because those are the two most important topics that are usually overlooked by the aspirants or by people who are preparing for coding interviews, right? So that's all. Uh, Thank you.